Welcome. Today we're diving into the fascinating world of modern physics and its crucial role in shaping the technology we use every day. From the smartphone in your pocket to the medical devices saving lives, modern physics is the invisible force powering innovation. We'll explore how discoveries in quantum mechanics, relativity, and other advanced fields have transformed our world. As we journey through each scene, you'll see just how deeply physics is woven into the fabric of our daily lives, often in ways we might not even realize. Let's begin by understanding what modern physics actually means and why it's so important for technology. Modern physics refers to the scientific principles and theories developed in the 20th century and beyond, such as quantum mechanics and relativity. Unlike classical physics, which deals with everyday phenomena, modern physics explores the behavior of matter and energy at atomic and subatomic levels. These breakthroughs have not only expanded our understanding of the universe, but also paved the way for groundbreaking technologies. As we move forward, keep in mind that many of the devices and systems we rely on today simply wouldn't exist without these revolutionary ideas. Quantum mechanics is one of the pillars of modern physics. It describes how particles like electrons and photons behave in ways that often defy our everyday intuition. This field has led to the development of technologies such as lasers, semiconductors, and even the microchips that power our computers and smartphones. Without quantum mechanics, the digital revolution would have been impossible. As we continue, you'll see how these strange but powerful principles are harnessed in devices all around us. Albert Einstein's theory of relativity isn't just a concept for physicists, it's essential for technologies like GPS. The satellites that help us navigate rely on precise timing, which is affected by both the speed of the satellites and the strength of Earth's gravity. Without accounting for relativity, GPS systems would quickly become inaccurate. This is a perfect example of how abstract physics theories have real, practical applications that impact our daily routines, from finding the fastest route to work to tracking deliveries. Semiconductors are the backbone of modern electronics, and their operation is deeply rooted in quantum physics. These materials, like silicon, control the flow of electricity in devices such as computers, smartphones, and televisions. The ability to manipulate electrical signals at the atomic level has led to smaller, faster, and more efficient gadgets. Thanks to advances in semiconductor technology, we enjoy powerful computing in the palm of our hands, and the pace of innovation continues to accelerate. Lasers, which stand for light amplification by stimulated emission of radiation, are a direct product of quantum physics. They're everywhere, from barcode scanners at the supermarket to high-speed internet connections and even in medical surgeries. Lasers work by controlling the behavior of photons, and their precision has revolutionized communication, manufacturing, and healthcare. The next time you scan a product or watch a Blu-ray movie, remember that quantum physics is at work behind the scenes. Modern physics has transformed healthcare, especially through medical imaging technologies like MRI and CT scans. These machines use principles from quantum mechanics and electromagnetism to create detailed images of the human body. This allows doctors to diagnose and treat illnesses more accurately and less invasively. The next time you see a medical scan, you're witnessing the power of physics in action, helping to save lives and improve patient outcomes. Fiber optic cables are the backbone of modern communication networks, enabling high-speed internet and global connectivity. These cables transmit light signals over long distances with minimal loss, thanks to the principles of total internal reflection in quantum physics. Fiber optics have revolutionized how we share information, making video calls, streaming, and instant messaging possible across continents. This is another example of how modern physics keeps us connected in our digital world. Solar cells, or photovoltaic cells, convert sunlight into electricity using the photoelectric effect, a phenomenon explained by quantum physics. This technology is at the heart of renewable energy solutions, helping to reduce our reliance on fossil fuels. Advances in material science and quantum mechanics have made solar panels more efficient and affordable, paving the way for a cleaner, more sustainable future. Every time you see a solar panel, remember the physics powering it. Transistors are tiny switches that control the flow of electricity in electronic devices. Their invention, based on quantum physics, sparked the digital revolution. Transistors are found in everything from computers to hearing aids, enabling complex computations and miniaturization. The ability to pack billions of transistors onto a single chip has made modern electronics faster, smaller, and more powerful than ever before. This is a testament to the impact of physics on technology. Superconductors are materials that can conduct electricity without resistance when cooled to very low temperatures. This property, explained by quantum mechanics, has huge implications for power transmission and magnetic levitation. Superconductors are used in MRI machines, maglev trains, and experimental power grids. They promise a future where energy can be transmitted more efficiently, reducing waste and costs. The science behind superconductors continues to inspire new technological breakthroughs. Light-emitting diodes, or LEDs, are everywhere, from traffic lights to smartphone screens. LEDs work by using quantum mechanics to convert electrical energy into light efficiently. They last longer and use less energy than traditional bulbs, making them a key technology for sustainability. The development of LEDs is a shining example of how modern physics can lead to practical, everyday solutions that benefit both people and the planet. Digital cameras and image sensors rely on the photoelectric effect, a concept from quantum physics, to capture light and convert it into digital signals. This technology has revolutionized photography, making it possible to instantly capture, store, and share images. From smartphones to security systems, digital imaging is now an essential part of our lives, all thanks to the principles of modern physics. Quantum computing is an emerging technology that uses the principles of quantum mechanics to process information in fundamentally new ways. Unlike classical computers, which use bits, quantum computers use qubits that can represent multiple states at once. This could lead to breakthroughs in cryptography, drug discovery, and artificial intelligence. While still in its early stages, quantum computing represents the next frontier in the marriage of physics and technology. RI machines use powerful magnets and radio waves to create detailed images of the body's internal structures. This technology is based on nuclear magnetic resonance, a concept from quantum physics. MRI has become an indispensable tool in medicine, allowing for non-invasive diagnosis of a wide range of conditions. The precision and safety of MRI scans are a testament to the power of modern physics in healthcare. X-rays and CT scans are vital diagnostic tools that rely on the physics of electromagnetic radiation. X-rays can penetrate the body to reveal bones and tissues, while CT scans use computer processing to create detailed cross-sectional images. These technologies have revolutionized medicine, making it possible to detect injuries and diseases quickly and accurately. The science behind them is a perfect example of physics in action. Nuclear power plants generate electricity by harnessing the energy released from atomic nuclei. This process, known as nuclear fission, is a direct application of modern physics. Nuclear energy provides a significant portion of the world's electricity and is a low-carbon alternative to fossil fuels. While it comes with challenges, such as waste management, nuclear power demonstrates the immense potential of physics to meet our energy needs. Particle accelerators are massive machines that use electromagnetic fields to propel charged particles to high speeds. These devices have been crucial in advancing our understanding of fundamental physics, leading to discoveries like the Higgs boson. Beyond research, particle accelerators are used in medicine, industry, and even art restoration. Their development showcases how modern physics drives both scientific discovery and practical innovation. Nanotechnology involves manipulating matter at the atomic and molecular scale, a field made possible by advances in modern physics. This technology is used in everything from medicine to electronics and materials science. Nanotechnology enables the creation of stronger materials, targeted drug delivery, and more efficient electronics. The ability to engineer at such a small scale is a direct result of our understanding of quantum mechanics and atomic physics. Wireless communication, including Wi-Fi and Bluetooth, relies on the physics of electromagnetic waves. These technologies allow us to connect devices without physical cables, enabling everything from mobile phones to smart homes. The principles of wave propagation, interference, and signal processing are all rooted in modern physics. Wireless technology has transformed the way we live, work, and interact with the world. Touchscreens and various sensors in our devices use principles from physics to detect and respond to our actions. Capacitive touchscreens, for example, rely on the electrical properties of the human body in materials science. Sensors like accelerometers and gyroscopes use physics to measure motion and orientation. These innovations make our devices more interactive and intuitive, enhancing the user experience. Modern batteries, such as lithium-ion cells, are based on principles of electrochemistry and solid-state physics. These energy storage devices power everything from smartphones to electric cars. Advances in battery technology have made portable electronics possible and are key to the growth of renewable energy. The ongoing quest for better batteries is a perfect example of how physics continues to drive technological progress. 3D printing or additive manufacturing uses precise control of materials and energy to build objects layer by layer. This technology relies on principles from physics, including thermodynamics and material science. 3D printing is transforming industries from healthcare to aerospace, enabling rapid prototyping and custom manufacturing. The ability to turn digital designs into physical objects is a testament to the power of modern physics and engineering. Smartphones are a showcase of modern physics in action. They combine semiconductors, sensors, wireless communication, and advanced materials, all rooted in physics. Every time you make a call, take a photo, or browse the web, you're using a device that brings together decades of scientific discovery. The compact power of smartphones is a daily reminder of how physics shapes our lives. Internet of Things connects everyday objects to the internet, allowing them to collect and exchange data. This network relies on sensors, wireless communication, and data processing, all made possible by advances in physics. IoT is transforming homes, cities, and industries, making systems smarter and more efficient. The seamless integration of physical devices and digital networks is a hallmark of modern physics and technology. Artificial intelligence relies on powerful hardware, including specialized chips and processors. These components are built using principles from quantum mechanics and semiconductor physics. Advances in hardware have enabled rapid progress in AI, from voice assistants to self-driving cars. The synergy between physics and computer science is driving the next wave of intelligent technology. Wearable devices, such as smartwatches and fitness trackers, use sensors and wireless communication to monitor health and activity. These technologies depend on advances in materials science, miniaturization, and battery technology, all rooted in physics. Wearables are making it easier to track our well-being and stay connected, blending science and lifestyle in innovative ways. Augmented reality, AR, and virtual reality, VR, create immersive experiences by blending digital information with the physical world. These technologies use advanced optics, sensors, and displays, all made possible by modern physics. AR and VR are transforming entertainment, education, and even healthcare, offering new ways to interact with information and environments. Smart home technology uses sensors, wireless communication, and automation to make living spaces more convenient and efficient. From voice-controlled lights to automated security systems, these innovations rely on physics-based technologies. The integration of smart devices is making homes safer, more energy efficient, and easier to manage, all thanks to advances in modern physics. Electric vehicles, EVs, are revolutionizing transportation with clean, efficient power. EVs use advanced batteries, electric motors, and power electronics, all based on principles from physics. Regenerative braking, for example, uses electromagnetic induction to recover energy. The rise of EVs is a clear example of how modern physics is driving sustainable innovation in mobility. Magnetic levitation, Maglev trains use superconducting magnets to float above the tracks, eliminating friction and allowing for incredibly fast travel. This technology is a direct application of quantum physics and electromagnetism. Maglev trains are already in use in some countries, offering a glimpse of the future of transportation powered by modern physics. Drones and robots use sensors, wireless communication, and advanced materials to perform tasks autonomously. The physics of flight, motion, and control systems is essential to their operation. From delivering packages to exploring hazardous environments, drones and robotics are expanding what's possible, thanks to the integration of modern physics and engineering. Satellites orbiting Earth rely on the physics of gravity, motion, and electromagnetic waves. They enable everything from global communication to weather forecasting and navigation. The precise calculations required for satellite launches and orbits are rooted in modern physics, making these marvels of engineering possible. Space exploration pushes the boundaries of physics and engineering. Rockets, spacecraft, and space stations all depend on principles like propulsion, thermodynamics, and materials science. Modern physics enables us to explore distant planets, study the universe, and even search for life beyond Earth. The quest to understand space continues to inspire new technologies and discoveries. Optical fibers aren't just for communication, they're also used in medicine for procedures like endoscopy. These fibers transmit light into the body, allowing doctors to see inside without invasive surgery. The physics of light transmission and reflection makes these life-saving procedures possible, demonstrating the versatility of modern physics in healthcare. Holography uses the interference and diffraction of light to create three-dimensional images. This technology is used in security, entertainment, and advanced data storage. The principles of wave physics and optics are at the heart of holography, opening up new possibilities for visualization and information management. Smart materials can change their properties in response to external stimuli like temperature, pressure, or electric fields. These materials are used in everything from self-healing coatings to adaptive building structures. The development of smart materials is driven by advances in condensed matter physics and materials science, leading to innovative solutions across industries. Acoustic technology uses the physics of sound waves for applications like noise cancellation, medical ultrasound, and audio engineering. Understanding how sound travels and interacts with materials has led to better speakers, clearer communication, and advanced diagnostic tools. The science of acoustics is another example of physics improving our quality of life. Thermal imaging cameras detect infrared radiation to create images based on temperature differences. This technology is used in everything from firefighting to building inspections and medical diagnostics. The physics of heat transfer and electromagnetic waves makes thermal imaging possible, providing valuable insights in a variety of fields. Photonic devices use light to perform functions traditionally done by electronics, such as data transmission and signal processing. These devices rely on quantum optics and materials science, offering faster and more efficient alternatives to electronic components. Photonics is paving the way for next-generation communication and computing technologies. Biophysics applies the principles of physics to biological systems, leading to advances in medical technology. Techniques like electrophoresis, fluorescence microscopy, and bioimaging are all rooted in physics. Biophysics is helping us understand diseases, develop new treatments, and improve healthcare outcomes. Modern physics has enabled the development of sensors and instruments for monitoring the environment. Devices that measure air quality, radiation, and climate conditions use principles from physics to provide accurate data. This information is essential for protecting public health and managing natural resources, showing how physics contributes to sustainability. Security systems, from biometric scanners to surveillance cameras, use advanced physics-based technologies. Techniques like facial recognition, fingerprint scanning, and infrared detection rely on optics, electromagnetism, and signal processing. These innovations are making our world safer and more secure, thanks to the ongoing impact of modern physics. Future holds even more exciting possibilities as modern physics continues to evolve. Emerging fields like quantum communication, advanced materials, and fusion energy promise to reshape technology in ways we can only imagine. The ongoing partnership between physics and technology ensures that innovation will keep driving progress, improving our lives, and expanding our horizons. As we've seen, modern physics is at the heart of countless technologies that define our world. From the smallest microchip to the largest power plant, the principles of physics drive innovation, improve lives, and open up new possibilities. By understanding and applying these scientific concepts, we continue to push the boundaries of what's possible. The story of modern physics and technology is far from over. It's an ongoing journey of discovery and progress.